Okay, this is my second session about the name node and the data nodes and everything. So I'll start off with what the name node is. The name node is the most important thing in an HDFS system because it keeps the directory of all files in the file system and the metadata about the files in the directories. So what it basically does is it holds all the information of where the blocks are of a given file, and also some of the metadata that's involved in it. So you, because now you have a distributed system where there are lots of computers, some of them get added in the process and some of them get removed in the process because they would go dead. In that case, you need a central control plane which can understand where the files are at any point in time, and then how to and also manage these files in a way that you have enough replication so that there is no data loss, and also the metadata that's involved in it, like if you go and try to query when this what is the metadata around the file, like what is the actual file name, because at the end of the day these are stored as binary blocks, but what is the actual file name of it, what is the last access time, and all that levels of metadata that's involved, it needs to keep track, it needs to be it needs to keep track of all that information and store it somewhere. So all this responsibility is on the name node. All the data nodes do is they listen to the name node and follow the instructions. So that's pretty much, that's why it's called a master slave architecture, because the master is the name node and the slaves are all the data nodes that are attached to the name node. So there are two things that you have to remember in a name node. One is the fs image and the other one is the edit log. So fs image is the snapshot of the file system metadata, which is used by the name node when it started. So when you restart a name node, right, it always starts in and safe mode. That's what they call. It starts in the safe mode, and what it does, it reads the file system image. And then once the name node is booted and it knows all the blocks where they are, all the data nodes that they are and all that, that's when it starts agreeing for edits on the blocks and all that. Until then, the name node is in the safe mode. You can't make any changes and stuff like that. It just needs to manage the cluster to make sure that it's in a state so that it can accept requests. And after that, any subsequent changes that happen after the boot and everything, it goes into the edit log. This is like your typical database redo log type of a thing, wherein all the changes that happen to the blocks go to the edit log. And these edit logs are eventually processed and compressed into the final value. So if there's an add, delete, update, and all that, everything is finally processed and it's put into the fs image. So these are the two parts of a name node process. So there are things that are done as part of the name node. So when I don't want to go into the data node, I'll go into the secondary name node. So in a this is a Hadoop 2, wherein you have a secondary name node, and after that, now you in the Hadoop 3 you have another technology, another way of doing it. So I will explain the Hadoop 3 part of it. Typically in a Hadoop 2 system, you have a secondary name node, and what the secondary name node is, it's always listening to the primary name node. And what it does is it takes all these edit logs and it compresses it. So this is what a secondary name node does. What it takes is it takes the fs image and it constantly takes the edit logs and it compresses it and it forms the fs image, so that when the name node restarts or something like that, or if the name node fails, it can take the fs image and restart it. So what happens is it does all the background processing for your name node so that the name node is offloaded, and also it also becomes the backup for your name node. So these are the two things that a secondary name node does. So if the name node crashes, the secondary name node becomes your primary name node. And in the meanwhile, if the primary name node is running, what it does is it takes all the edit logs, compresses it, and rebuilds the fs image so that whenever you restart it, it doesn't have to reprocess all the edit logs. So these are the two things that that a secondary name node does. So this is what it shows here. So the name node is sending all the fs image and the edit logs to the secondary name node, and it's merging everything into the fs image and sending it back to the name node. Just in case this name node crashes, the secondary name node becomes your name node. And all the data nodes here will be sending the block reports. Like these are the blocks that are available in my node. These data nodes will be sending those block reports to the name node. And the name node, what it does is every time it goes and looks at, or it keeps a checkpoint to see that everything is up to date, so that it doesn't see any discrepancies. What Just imagine one of the data nodes going dead. That means there's no heartbeat going back to the name node. So the way the data nodes interact with the name node is it sends heartbeats back to the name node. That's how the data node name node knows that the data nodes are still alive. So let's suppose you want to add 10 machines to your Hadoop cluster. You're not stopping or restarting any of them. You're starting 10 data nodes and you're pointing them to the name node. So what happens is these data nodes will be sending their heartbeats to the name node, saying that they're available. And they also will be sending their block reports. That is how many blocks are there in their data nodes. When these block reports go into the name node knows, oh, these computers are available for me, the storage is available for me, and these are the blocks that are available in these data nodes. So once that information goes, it keeps track in the registry. Okay, these are the computers that I have, and these are the blocks that I need replication. Let's suppose one of the block gets updated, the other replicas need to be updated. Those are done asynchronously. So this process is also done by the name node. It manages it with the block reports and also with all the flags that it has to identify the outstanding updates that it needs to do. So that part is actually done by the name node. So that the okay, the name node, what the data node in this that's explaining is the data node sends doesn't store any information. It just holds on to the blocks and it does the compute. So that's what this actually is actually talking about. So now I'll shift to Hadoop 3. So this is all the Hadoop 2 version that is there, but the latest and the greatest is the Hadoop 3 version, which is how this is how it looks today. So you have the name node and they have created journal nodes. So the journal nodes are pretty much doing a very similar activity as what the secondary name node does. And there is a standby node. There is no more a secondary name node required because the standby node is actually going to be your name node when the primary name node dies. And what these journal nodes are doing is they're taking the edits and they are rebuilding your FS image. Instead of the secondary name node doing that, now you have a fleet of images, the fleet of nodes doing that. Those are called the journal nodes. So that's what this actually talks about. So you have a name node which is getting all the block reports, and all this information is going to the journal nodes, which are having a shared edit log storage. So all these are actually sharing the edit logs, and they are updating the edit logs very quickly, and then they're passing on to the the standby node, so that when this crashes, this can get active. So that's what the new architecture is about the secondary name node. Sorry, the standby node. So this is a high level of the name node, and I'll stop the recording, and then I'll start with I'll take a few questions, and then I'll start with the data nodes.